Hi everyone, my name is Annie Young. So I'm currently the postdoc working at the Department of Fish Wildlife Conservation Biology Department at Colorado State. And I'm also working with the NWRC here at VerCauteren. So my topic for today is to talk about the effect of social structure and management on the risk of the disease establishment in the wild pigs. So I know everyone is currently suffering the drama caused by the coronavirus, but before the coronavirus becoming a problem, people are pretty worried about the disease called African swine fever, especially in some Eurasia countries, because it caused dramatic loss in the livestock industry. But here in the US, we are also worried about what if the disease is going to come to the US. So today we're going to take the example of the African swine fever and look at how do the contact structure of the wild pigs going to influence the ASF transmission. So we know the contact structure could significantly affect the disease transmission dynamics. And it's important to understand the contact structure of the wild pigs. What does the contact structure of them look like? So in the homogeneous framework, we will have in the contact network, we will have the nodes to be represented by the individuals, and any pair of the animals could have equal probability to get the contact. But we know it's never going to be the cases because the spatial distribution of the animals is going to influence the probability of them to get the contact. Say, for example, the animals that are more closer to each other is much likely that they're going to contact more comparing to the ones that are apart away from each other. And for some species, because they were kind of living in some of like the spatial hierarchy, so we will have like different type of the family groups. And then we're going to have like this meta population scenario that in the contact network, the nodes will be represented by the host. And when we add all those three features together, we will get how the contact network of the wild pigs look like. So we see both the spatial structure and the social structure will influence their contact structure, and the contact rates could vary significantly from individual to individual. So for this research, we basically have three objectives. Firstly, we're going to look at how the general contact structure of the wild pigs look like. And typically, we're going to look at the demographic characteristics and how the spatial distributions affect the contact structure. And secondly, we did some management tactics in the study site. So here we're going to try to quantify how does the baiting and removal strategy going to affect the contact structure. And finally, we'll use what we learned from the contacts to inform the African swine fever transmission. So the data we got are the proximity loggers and the GPS data from the wild pigs in two study sites. The SRS in South Carolina, the Merrick is in Florida. So the study periods for the two study sites are different, and also we see the sampling schemes in the two study sites are different. So we kind of have to use different subset of the data to address different research questions we're interested in, and I'll talk about that in details later. And as I've mentioned, like we did some management tactics in one of the study sites, which will be the SRS sites. So basically from July to August, we started to put the bait piles to bait those wild pigs. And since the September the 14th, we started to remove the pigs. So in terms of the contacts we're interested in this study, here we are typically interested in the direct contacts and the indirect contacts. So the direct contact is defined by the contacts that are directly recorded by the proximity loggers. So which means that, say, for example, if the two pigs approaching to each other within a 5-meter range, we will see there's a direct contact between those two individuals. And for the indirect contact, it only occurs during the baiting periods. So when the two pigs contacting the baiting piles within a 5-day interval, we will see there's the indirect contact between those two individuals. And we select the 5-day time interval based on how long the African swine fever virus could persist in the environment. And normally when we are interested in the contact structure, we're typically interested in two features. The first thing is the contact heterogeneity. The second thing is the contact rates. The contact heterogeneity is talked about, is defined as like how many other animals an animal is connected to. And here we normally use the unweighted degree to quantify that. And the contact rate is defined as how many contacts an individual have over time. So say here we put the weights on the edges of the network. So say these two individuals have 20 contacts in a specific time frame. And normally we will use the weighted degree to quantify the contact rate. So for the first objective, we firstly look at how do the demographic factors in terms of the sex, age class, and group membership affect the contact structure. And here we use the SRS data before baiting and removal to address this question, because we only get like the sex, the age variation in the SRS sites. And we use the negative binomial hurdle model to address the question. So the hurdle model will include two processes. There's the binomial process to capture the contact probability, and there's the negative binomial process to capture the count process. And the covariance set here is like the ones that we incorporated in the final models. So what we found in the results are the female adults and the male sub-adult turn to connect with more individuals, and the male sub-adults in general contact less individual, but there's significant variation in the contact heterogeneities, which will be the unweighted degree. And for the contact rates, we found the female adult and female juveniles have much higher contact rates comparing to the other sex age class, and also the within group contact rate is much higher than the between group contact rates. And we also looked at how do the spatial distributions affect the contact structure. So for this sub-research question, we use the adult-only data with the GPS data available from the two study sites to address the question. So here we incorporate two measurements of the spatial distributions, the home range distance and home range overlap. And what we found is most of the contacts occurs when the home range distance are less than 2 kilometers, and there's barely no contact when the home range distance are greater than 4. And for the contact rate, we found the rate is much higher when the home range distance are less than 1 kilometers. So as I've mentioned, like we did some management tactics in the study sites. So the figure here shows three observed networks in 3 different time frames. So the left one is like before the baiting and removal, and the middle one is during the baiting. So we see during the baiting, we have two types of the ages. One is the thicker one is like the direct contact, and the thinner one is the indirect contact. And during the and the final one is like during the removal. So we see it's likely that the percutation could possibly affect the contact structure of the wild pigs. So the second objective here was trying to quantify how do the baiting and removal affect the contact structure of the wild pigs. So here we use the SRS, use the data from the SRS site for the whole study period. And typically we're interested in 4 types of the contacts: the within group direct contact, between group direct contact, within group indirect contact, and between group indirect contact. So what we found is firstly, we didn't find significant removal effects on the contact structure of the wild pigs, which is pretty interesting. So one of the possible reasons is that, so we see the numbers here. So those numbers are the proportion being removed in the whole population in the study sites, and the proportion being removed in the sampled population in the study sites. So we see like those numbers are not like huge numbers, which means that the removal efforts is pretty minor. So that's possibly why we didn't see the significant effects of removal on the contact structure. And we found during the baiting period, we started to incorporate the indirect contact, but the indirect contact rate is not very high. So that's possibly because, so even though we put like 9 baits in the study sites, but like some of them probably located outside of the home range of the sampled pigs, so they're not gonna accessing every bait piles. So that's possibly why we didn't see like the huge numbers in the contact rates of the indirect contact. So finally, we use what we learned from the network to from the contact network to inform the African swine fever transmission. So here we typically measure the metric called R0. I guess many of you probably heard about it pretty often recently because of the pandemic. So for any of you are not familiar with this terminology, so the R0 is defined as the average number of the individuals that will contract the contagious disease from an infected host. So basically, the R0 is the metric to measure like how contagious the disease is. So here we calculate the R0 for the African swine fever based on the SEIR framework, and we incorporate the unweighted degree in the calculation of the transmission rates. So one thing I'd like to highlight is that here, because our calculation with the of the R0 would require like fixing some unknown parameters. So we kind of have to scale the R0 to 0 to 1 to show the relative changes rather than use the actual number of the R0. So here we see the figure here is the relative R0 ranges from 0 to 1 versus the different degree distributions in different time frames. So we see the relative R0 decrease naturally as the degree distribution decrease, and then it pumps up during the baiting period because of the introduction of the indirect contact. And another thing I like to highlight is that, so remember, I've been mentioned that we didn't see the significant effect of the removal on the contact structure, but we see the R0 drop significantly during the removal period. That's mainly because of the reduction in the host density, which was the factor included in the calculation of the R0. So finally, the take-home message of this study, we found the female adults connect inside and outside of the social group, and the male adults connect between different groups. So those ones could be important to focus on in terms of disease management. And we found most of the contacts occurs when the home range distance are less than 2 kilometers, and there's barely no contacts when the home range distance are greater than 4. And those numbers could probably help with identifying like the curling radius in the disease surveillance and control programs. And we also found like during the baiting strategy, we'll introduce the indirect contacts. And here, even though we don't have a large, we didn't see like the large number of indirect contacts, but it still increased the relative R0 of African swine fever by about 47%. And finally, we found that removing 10% of the pigs probably are not going to have effect on the contact structure, but it will decrease the relative R0 of the African swine fever significantly by about 80%. So at the end, I would like to acknowledge all the funding agencies and all my collaborators. And thank you all for your listening, and please feel free to contact me if you have any questions.